What is up and how's it going, my ferns? Last week I completed a movement system. In the future, you can expect an update to handle slopes. But for now, we're going to move on to the entanglement feature. Let's refresh ourselves on what the entanglement mechanic will entail. An entangled object shares physics interactions with any other connected object. The example I showed in episode 1 was crossing a large chasm with two objects opposing one another. In this scenario, the player will entangle both objects and then push one of the objects over the chasm using the connection between the two. And thus we've created a platform to jump across. This same concept also applies to blockages in the upwards and side-to-side directions. So in my game Entangled, the player will be able to interact with the environment through three main ways: the entanglement effect, physically colliding and pushing free objects, and using an interact to grab onto free objects or trigger some event. Since all grabbable objects are going to be entangleable, I'm going to create a base class called GrabbableObject that I'll extend another class EntanglementObject from. This class will be straightforward enough. I simply need it to store the rigid body 2D and create a getter function that returns if it's in use. Both those variables need to be protected. That way the extended EntanglementObject class will be able to directly manage these variables. This is all we need to get done before starting the entanglement object. So now I can address how exactly I'm going to be going about the entanglement implementation. I had a few ideas for how I could go about making entanglement actually work. The first was to You donut! You're overcomplicating things! But my physics-based... Nay. But the math is so... I said nay! Then how? The fixed joint. Then what would happen to the rotation? You don't want rotation, you dingus! I don't want rotation. Fixed joint 2D. Fine, I'll use fixed joint 2D. Good. Now get back to work. So the entanglement object is going to be extended from the Grabbable object we made previously. For the attributes, I'm going to need a fixed joint 2D, a particle effect to indicate the entanglement, a sprite renderer if I feel lazy and don't want to use the particle effect, and finally, the spawn rotation and position for resetting the object. None of the logic for the entanglement is going to be stored here. Entanglement objects only know what their state is, and changes to it will come from the EntanglementManager class. All I need is an entangle method that says this object is now in use, it no longer can rotate, and to play the entanglement effect. The detangle method will free the in-use boolean and remove the constraints placed on the rotation. The manager class will hand over the object that is joined to this one using the connect rigid body method. The clear rigid body method will be used by the manager class to clear the joint information. Finally, the reset object will be used for resetting objects. I should probably move this into the Grabbable object class later down the line. Before I go ahead and start on the EntanglementManager class, let's demonstrate that the fixed joint 2D actually works as a solution. So here are two squares.
Just like the simulation.
I've given them both rigid bodies and a collider, and a fixed joint 2D. I finally set square A's fixed joint to connect to square B's. So as you can see, I can now Okay, let's turn rotation off and try that one again. As you can now see, I have made a platform to jump across the chasm with. Now I need to just give the player the ability to assign and unassign these fixed joints, and the core game mechanic should be mostly implemented. Sweet! Functionally, the Entanglement Manager is going to be quite simple. It's going to be holding references to the currently entangled objects. It will receive a trigger to capture and assign object references to a previously captured fixed joint. The first capture will simply be recorded. Each new object will be given to the previous one, linking all the entangled objects through their fixed joints. And at long last, we shall finally get coding. Before you is the Entanglement Manager script. I decided the manager should be responsible for shooting the entanglement effect, so I gave it a transform where an entanglement bullet will spawn. I then needed a bullet prefab to instantiate, which I called entanglement effect. The only other global variable will be the actual list of entanglement objects currently entangled. Recall the update data method that receives the data to operate this script. From here we can call the two main functions shoot entanglement and detangle all objects. Shoot entanglement requires a target vector that is now being provided in the update data method. Looking at the shoot method, we can see how I use the target vector to calculate the direction of the target. I then create a new entanglement effect and place it at the entanglement origin position. The next two lines are getting the actual bullet script so I can give it the direction to fire in and reference this manager so it can use the capture method. When the bullet script makes contact with an entanglement object, it will run this capture object method. This method checks to see if the object is already in use or not, and then sets the object to entangled. If the object is not first to be captured, it will assign that object to the previous captured fixed joint, after which it adds the new object to the entanglement list. The release of entanglement objects will be commanded through the detangle boolean in the update method. Detangle all objects simply runs a loop releasing each object. Releasing an object takes the object out of the list and uses the detangle method the object provides. I swear I'm almost done talking about code. There's one more thing, it's short, I promise. The bullet script. The script manages a rigid body that is initialized to move at an arbitrary velocity I set to 20 in a target direction. When it hits an object, it will run the capture object method from the manager that initialized it. The bullet prefab is not affected by gravity, which I set in the rigid body. For the time being, the target is hard-coded in the player controller, which I will update later. We have at last returned to the scene. I've gone ahead and added a particle effect to the square. I also created a new bullet prefab, which I have given to the Entanglement Manager. As you can see, there are now 2 free cubes that I can push around freely. If I click my left mouse button, I shoot a bullet to the right of me. If that bullet hits a valid free object, it will entangle it. Now let's do the other one, and both my objects are lit up. We should be able to push them around just like before. And ta-da! Entanglement is done. For now. Now that we're capable of shooting an entanglement bullet, next episode is going to be about creating an input that will actually aim it. In other news, I'm considering entering the CJM hosted by Polymars, so you might see a week-long break from Entangled, but probably not since I hate myself. A link to the jam will be in the description below. It's for a fundraiser to help clean up the oceans that was made by Mr. Beats. Now I finally get to stop talking so you can enjoy Michael's sweet tunes.